Good afternoon. Over the last 3 days, we have been celebrating a century of MIT aerospace innovation. We've looked at the lessons learned from the past, the excitement of the present, and speculated about the future. The common thing underlying this incredible 100 years has been the passion of the visionaries. People like Hans Sacker, Doolittle, Gartner, Draper, and Siemens. Who better than Elon Musk to add to this roster of visionaries and culminate this symposium and join us as we launch our second century of aerospace at MIT. Elon is an innovator and an inspiration to a new generation of engineers and entrepreneurs. First of all, Elon, thank you very much for coming. It's a pleasure to have you here and welcome you to MIT.
Great, thank you for having me.
So perhaps I'd like to start and ask you if you could elaborate a little bit on what we've seen on the video.
Okay, that was quite a lot. Well, I mean, what we're seeing there is, and I just like our communications team put it together, so I just saw it for the first time in the back there. Like, probably a bit too much slow-mo. So what we're seeing there is our Falcon 9 rocket and our Dragon spacecraft, and then we're seeing some of the initial tests of the reusable version of Falcon 9 that is capable of taking off and landing, which is reusability is really, I think, the critical breakthrough needed in rocketry to take things to the next level.
When do you think you might be able to fly an operational reusable first stage?
Well, we've been able to soft land boost the rocket booster in the ocean twice so far. Unfortunately, it sort of sat there for several seconds, then tipped over and exploded. Much, yeah, just it's quite difficult to reuse at that point. And unfortunately, it's as tall as a 14-story building. So, when a 14-story building falls over, it's quite a belly flop. So what we need to do is to be able to either land on a floating platform or ideally boost back to the launch site and land back at the launch site. But before we boost back to the launch site and try to land there, we need to show that we can land with precision over and over again. Otherwise something bad could happen. But if it doesn't boost back to where we intended. So for the upcoming launch, I think we've got a chance of landing on a floating landing platform. We actually have a huge platform that's being constructed at a shipyard in Louisiana right now, which is, it's huge-ish. I mean, it's about 300 feet long by 170 feet wide. That looks very tiny from space. And the leg span of the rocket is 60 feet. So, you've got, and this is going to be positioning itself out in the ocean with, with engines that'll keep it, and it will try to keep it in a particular position. But it's tricky. You've got these big rollers and GPS errors. So, so it's not anchored because it's like out in the bloody Atlantic. So, that's we're gonna try to land on that on the next flight, and if we land on that, then I think we'll be able to refly that booster. But it's probably maybe not more than a 50% chance or less of landing it on the platform for the first time. But there's a lot of launches that will occur over the next year. So there's at least a dozen launches that will occur over the next 12 months, and I think it's quite likely, probably 80–90% likely, that one of those flights will be able to land and refly. So I think we're quite close.
I'm curious to know why you chose to go with a retrothrust rocket for landing as opposed to just wings and wheels and land on a runaway like the shuttle, say.
Yeah, there's a couple reasons. If you like the long-term ambition of SpaceX is to develop technologies necessary to establish a self-sustaining city on Mars or civilization on Mars. And wings and a runway don't really work if you're going somewhere other than Earth. The moon doesn't have an atmosphere, so wings and wheels are, there's no runways and there's no atmosphere. Not a good choice for the moon. And then on Mars, there are also no runways, and the atmosphere is very thin. And so unless you try to land something at supersonic velocity, it's just not a good choice for Mars either. So you really have to get good at propulsive landing if you want to go someplace other than Earth, which is why you have rockets, because obviously aircraft work quite well on Earth. But even for Earth recovery, when you really look at it, even if other planets had atmospheres, the penalty for propulsive landing is quite low. Like you can just do easy calculation of what's the terminal velocity, and then how long do you have to fire the engine at what G level to get to zero velocity. And then if you do some interesting things, like if you look at our landing gear, they're essentially like giant body flaps. So the drag, when we deploy the landing gear, the drag massively increases. And so we have dual use of the landing gear as giant body flaps and as landing gear. And it actually cuts the terminal velocity in half. And therefore, the fuel, the propellant that we need to stop the vehicle in half. And actually, it's quite an efficient method of landing precisely. You can use less mass if you want to do parachutes or water landing. But then reusability is negatively affected.
Any near-term plans for a reusable second stage rocket?
The next generation vehicles after the Falcon architecture will be designed for full reusability. I don't expect the Falcon line to have a reusable upper stage, just because with a kerosene-based system, the specific impulse isn't really high enough to do that. Mm-hmm. And a lot of the missions we do for commercial satellite deployment are geostationary missions. So we're really going very far out. These are high delta velocity missions. So to try to get something back from that is really difficult. But with the next generation of vehicles, which is going to be a subcooled methane oxygen system, where the propellants are cooled to close to their freezing temperature to increase the density, we can definitely do full reusability. And that system is intended to be a fully reusable Mars transportation system. So not merely to low Earth orbit, but all the way to Mars and back.
What are we talking?
Full reusability.
3 years? 5 years?
I'm an optimistic person, but
always.
I think we could start to see some test flights in the 5 or 6 year time frame. Mm-hmm. But we were talking about a much bigger vehicle.
Much bigger vehicle together.
Yeah, and we're also going to be upgrading to sort of a new generation, a harder engine cycle, which is a full flow staged combustion. So what we have right now is an open cycle engine. So right now I'd say like engines are our weakest point at SpaceX, but they will become as strong as the structures and avionics in the next generation.
Okay. Thank you. So let me change a little bit. SpaceX is only 12 years old, and you have shown that in some aspects you can compete head-to-head with much more established launch service providers like Lockheed and Boeing and the Europeans. To what do you ascribe this ability of a young and conventional company to take on the establishment?
Sure, and actually let me just clarify another point. Like right now, our weakest point is engines with respect to specific impulse, but not with respect to thrust to weight. We actually have the highest thrust to weight of any engine, I think maybe ever. But our specific impulse, the efficiency of the engine is about 10% worse than a staged combustion engine using the same propellant. In terms of our competitiveness, I think it mostly comes down to our pace of innovation. our pace of innovation is much, much faster than the big aerospace companies or the sort of country-driven systems. And this is generally true. If you look at innovation from large companies or from smaller companies are generally better at innovating than larger companies. And it has to be that way from a Darwinian standpoint, because smaller companies would just die if they didn't try innovating. Because otherwise people just keep buying the product from the big company. But I mean, and so then, well, why is SpaceX more innovative? I think it's probably because we've got like a super engineering-driven culture. I mean, we're running kind of the Silicon Valley operating system. It's kind of hard to describe. Like, it's like, how do you describe Linux? Like, like Linux is more efficient than some other operating systems.
to remain nameless.
But like, exactly why? I was like, you really have to get into the weeds. But you have a fairly flat hierarchy. You promote rapid communication. Sort of a best ideas wins culture, as opposed to this, having the seniority of the person decide the solution. Which, I mean, that should never be the case in engineering. It should always be, a rational basis. And I also believe that in terms of at the leadership level, I'd much rather promote someone who has strong engineering ability than so-called management ability. Like we do hire some MBAs, but it's usually in spite of the MBA, not because of it.
Okay. I think that deserves an applause. You're really pushing the concept of reusability as a way to affordability, but would you agree that the only way you justify making a more expensive reusable vehicle is if you can guarantee a minimum frequency of flights? And is the market there? How are, in the say, 5 years, 10-year period, who is going to provide that demand? Where is it going to come from?
Well, I mean, it is a chicken and egg sort of situation. I mean, the reason that there's low demand for spaceflight is because it's ridiculously expensive. So somebody, at some point, somebody has to say, okay, we're going to make something that's much more affordable, and then see what applications develop. That's what has to happen. I mean, the situation in rocketry is, it's like if an aircraft, imagine if aircraft were single use, then how many people would fly? I mean, like the flight rate would be really low. You buy a 747, it's like $250 million, so maybe $300 million, and you need 2 of them for a round trip. So nobody's paying like $500 million to fly it from Boston to London. And if that were the case, there'd be like a very small number of flights for like scientific and military purposes, and people would say, wow, the market for aircraft is so tiny. People really love going by boat. It's nonsense. So if we have rockets that are reusable, we could reduce the, fully reusable and can get to a decent flight rate. The potential is there to get a 2 order of magnitude reduction in the cost of space transport, which is vital for establishing a self-sustaining civilization on another planet, or even on the moon or some sort of L5 colony or whatever. But you really need to get the cost. We need a 2 order of magnitude improvement at least in the cost of transport. In fact, I mean, relative to the estimates of what it costs to do a Mars mission, a manned Mars mission, where I think like some of the lower estimates are at the $100 to $200 billion level, for a 4-person mission. We need more like a 10,000-fold reduction.
To make it viable.
Yeah. Well, I mean, so people can afford to go.
Do you see space tourism as a customer? People wanting to just pay to be in orbit?
Yeah, I mean, I think there's some sort of private space flight is going to be some amount of market. Yeah, I don't really know. I mean, we're trying to advance rocket technology, and I mean, on the one hand, if we are even, if we get even slightly towards the overarching goal of Mars colonization level technology, like if we just get slightly there, we certainly have a viable business in launching satellites and servicing the space station, that kind of thing, because, like, yeah, I mean, for like 5%, so it's not like there's still a very viable business doing Earth orbit stuff,
there is enough there.
and even if like for 5% towards that goal, we're like vastly more competitive than the other rocket companies. So we do have a lot of people gang up against us these days.
Okay, I understand. Let's talk about Mars. That's what really excites a lot of the people in the audience, a lot excites many of us. How are we going to get there? First of all, what are in your mind, say, 2, 3 top technologies that we need to develop, that we need to improve to get us closer to where we want to be?
Sure.
And second, I also like some comments as to what would be useful intermediate missions. Are we going to use the moon? Is the moon
I think
a necessary step on our way to Mars?
I don't think the moon is a necessary step, but I think if you've got a rocket and spacecraft capable of going to Mars, you might as well go to the moon slung along the way. I mean, it's like crossing the English Channel relative to going to Mars. So it's like, if you have these ships that can cross the Atlantic, would you cross the English Channel? Probably.
But you don't see it necessary from a logistics perspective.
No, definitely not. It's definitely not necessary, but you probably end up having a moon base, just because, like, why not? But in terms of the key technologies, I mean, obviously it'd be great to have some sort of fundamental new thing that has never existed before and like pushes the boundaries of physics. That would be great. But as far as the physics that we know today, I think I actually think we've got the basic ingredients are there. Like I mean, if you do a densified Methalox rocket with on-orbit refueling, Earth orbit refueling, so you like load the spacecraft into orbit, and then you send a bunch of refueling missions to fill up the tanks, and you have the Mars colonial fleet essentially that gets built up during the time between the Earth-Mars synchronizations, which occur every 26 months, and then the fleet sort of all departs at the optimal transfer point. I think we don't need anything like we don't need any sort of thing that people don't already know about. I believe we've got the building blocks, but the mass efficiency is extremely important. So having better heat shields that are obviously are reusable.
Is radiation on humans?
Pardon me?
Radiation on humans a concern?
Yeah, I mean, things that can mitigate the radiation effects, certainly. I mean, I think the radiation effects are generally way overblown. Because if we went to the moon, went like 2 weeks in deep space, Buzz Aldrin's still around.
Many other folks that went are also in the audience.
Yeah, great. I mean, so like obviously, it didn't cause like they're still alive and they seem okay. People have been up in the space station for like a year or more. They're okay.
Okay.
So I don't know. I mean, if the things we can do to mitigate the radiation en route, by effective placement of the water, so let's say the water you bring there, like put that in the direction of the sun. But I mean, I really think we've got the sort of essential agreements. I mean, we do need an efficient propellant depot on Mars. So that's, but I mean, I think this is like, there's obviously a lot of hard work and engineering that needs to be done. But it's there, like the pieces are there.
Do you foresee robotic missions ahead of human missions going to Mars and to prepare the ground for people?
Yeah. I think that'd be, yeah. I mean, we have like, we have rovers on Mars
Already?
and whatnot already. So I think we'll see more robots on Mars, and we probably want to make sure that the propellant depot works. There'll be an automated propellant depot. And there's some questions as to what do you do for power generation on Mars? Do you have a nuclear reactor? Then you've got to carry the nuclear fuel there. And reactors are fairly heavy. Do you do some lightweight solar power system? To sort of maybe big inflatable solar arrays or something like that. So just power generation on Mars, I think, is an interesting problem. And then just figuring out like how to get all of the bits of efficiency right for creating, say, methane and oxygen on Mars. Mars has got a CO2 atmosphere, and there's a lot of water sort of buried in the soil that you can get. So.
Question that has been discussed over the past couple of days. Should we be considering one-way only trips to Mars? What's the best approach to colonize the planet? Is it, what's your view? Is that socially acceptable? Do you think people will sign up to do it?
I think there's plenty of people that will sign up for a one-way trip to Mars. But
if we could have a show of hands, who would consider such an option? I see some, not many, but perhaps enough for a couple of missions.
So certainly be enough. I mean, I think it's sort of like, is it a one-way mission and then you die? Or is it one-way mission and you get resupplied? That's a big difference.
Really good. Wait for the second option.
Yeah, exactly. But I mean, I think it ends up being a moot point because you want to bring the spaceship back. Like, these spaceships are expensive, okay? They're hard to build. You can't just leave them there. So whether or not people want to come back or not is kind of, like, they can jump on if they want, but they need the spaceship back.
Thank you.
I mean, it's kind of weird. Like, there's like a huge collection of spaceships on Mars over time. And we're like, it's like, maybe we should send them back. I mean, of course we should send them back. So I think that's for sure like necessary, particularly if you say we want to have a colony of some kind that's of significant size. Yeah.
Just one question. Looking at the Apollo experience, are you concerned that, say we land humans in Mars in say 10, 15 years, and then all of a sudden the excitement is done, we've done it, and just go and rest for the next 50 years like we did with Apollo? Is that something that concerns you?
Yeah, well, that's why I think we should really be setting the goal as the creation of a self-sustaining civilization on Mars, not simply a mission to Mars, because then we risk, it would be awesome and cool, and it would be a new high-altitude record, and great pictures and stuff. But I mean, it's just not the thing that fundamentally changes the future of humanity. And this, I mean, I should sort of explain perhaps the rationale for. Why I think it's important to establish a self-sustaining colony on Mars, because I think some people are aware of that, but probably most people aren't. And you hear all these rebuttals, like, aren't there all these problems on Earth that we need to deal with, and shouldn't we focus on that? And the answer is yes. I mean, our primary focus should be problems on Earth, but I think that there should be some small amount that's given over to the establishment of a colony on Mars and making life multiplanetary. By small amount, I mean some number less than 1% of our resources. So, it's not as important as say healthcare, but it's more important than, like, say, cosmetics. I mean, I'm in favor of cosmetics. I like them; they're great. But lipstick or colony on Mars, I don't. So people may have different opinions, but so I think we should have that, and because the future of humanity will fundamentally bifurcate along the lines of either single planet species or multi-planet species, and a multi-planet version of humanity or of humanity's future is going to last a lot longer. We will propagate civilization into the future far longer if we are multi-planet species than if we are a single planet species. And and so it's like planetary redundancy, backing up the biosphere. We've got all of our eggs in one basket here. We should try to protect that basket and do everything we can, but there are some risks that are just extremely difficult to mitigate, and some which we will ultimately not be able to mitigate. So it just seems like the right thing to do. And then the next question is, well, should we do it now, or should we wait for some point in the future? And I think it's the wise move is to do it now, because the window of technology for this is open, and it's the first time that window has been open in the 4.5 billion year history of Earth. Okay, that's a long time. and I certainly hope that the window will be open, for forever, but it may also close. And if you look at the history of technology in various civilizations, you look at, say, ancient Egypt, where they were able to build these incredible giant pyramids, and then they forgot how to build pyramids, and then they couldn't read hieroglyphics. Or you look at, say, Roman civilization, and they were able to build these incredible aqueducts and roads, and then they forgot how to do that. They had indoor plumbing, then they forgot how to do indoor plumbing. It's like, it's just, there's clearly been a cycle with technology. And hopefully that's an upward sloping sine wave that continues on to be really great in the future. But maybe it doesn't. Maybe there's some bad thing that happens. And so for 1% of our resources, we could buy life insurance for life collectively. And I think that would be a good thing to do.
Good idea. Thank you. I'm sure the topic of Mars is going to come again, because in a few minutes I'd like to open the floor for questions. But I have a couple more questions I'd really like to get your opinion on. It's related to your association, your involvement with Tesla and Solar City. Could you tell us a little bit about your announced plans to construct a battery gigafactory? And can you elaborate on this? What's the driver? Is it satisfy demands, reduce costs, improve efficiencies, or all of the above?
For the gigafactory?
Yes.
So the gigafactory is like the least bad solution we could come up with, honestly. I think it's actually pretty cool the way it's worked out, but we're just faced with a simple problem of, if we want to make electric cars, we need enough batteries for the electric cars. And so, last year, all lithium ion production combined was 30 gigawatt hours approximately. That's nothing, okay? Or at least it's nothing when you consider, like, if you want to make 500,000 electric cars a year, that's how much you need. And there are 100 million new cars made every year. There are 2 billion gasoline or diesel cars on the road worldwide. So just do the basic math. You don't just need one gigafactory, you need like 200 gigafactories just for new car production. And that assumes you're only going to replace the fleet at the existing rate, which has it refreshed every 20 years. Given that we want to try to get to full capacity at our Fremont plant in California of 500,000 vehicles a year, we need 500,000 vehicles a year of batteries. And obviously we can't use all of the other factories in the world combined, because people want cell phones and laptops and other things. So therefore, we have to build this factory. And then we found we have a great partner in Panasonic. Panasonic's taking care of the cell formation part of it. There are actually many aspects to this, because you've got sort of anode, cathode, separator, electrolyte can at the precursor level. You've got sort of raw materials coming in from the mines that sort of feed into a variety of other companies, like Sumitomo Metals and Mining and Hitachi and others, and that they do the precursor processing, and then Panasonic takes the anode and cathode material separator and whatnot, puts that into a cell. Then it goes into a Tesla section, which creates the module, which is all the electronics and the packaging and the conductors, the safety mechanisms and the cooling loops. Then the modules go into the pack, which then has a lot of crash structure associated with it, and the pack goes in the car. And then obviously Tesla is kind of the landlord of the whole thing as well. Anyway, that's like, short of doing that, there was no way to scale, so that's why we did it.
The reason why I brought that up is because as much as we love Teslas, we are in an aerospace department where we are really interested in the potential for electric aircraft.
Sure.
And
I love the idea of electric aircraft. Everything will go electric, everything will go fully electric except for rockets. It's ironic.
We think that in terms of energy density, to make transport aircraft feasible, you would need improvements of the order of 10 to 100.
What? No, that's not okay. Wait, when you say 10 to 100, off what baseline? What do you mean?
Current ion lithium.
Oh, no, definitely not. In my opinion at least, where we are right now is at roughly, for a cell that doesn't have like lots of other drawbacks, which people always forget to mention when they talk about battery breakthroughs. There's many parameters that are important for a battery, and they'll, hardly a week goes by where there's not some huge breakthrough allegedly in batteries, but like the bullshit factor is outrageous. But for real cells that actually work and don't have like some huge drawback, they're currently at about 300 watt-hours per kilogram. And if to have a compelling aircraft, you only really need about 400 watt-hours per kilogram, provided the percentage of cell on the aircraft is high. It doesn't need to be anywhere near as high as it is on a rocket, but if it's sort of at the 70% level at 400 watt-hours per kilogram, you can do very decent range. And if you sort of move it up to the sort of mid to high 70s, you can go transcontinental. Not intercontinental, but sort of west coast to east coast. So you need an efficient aircraft, but that's approximately, by my calculations, the numbers you need: 400 watt-hours per kilogram, mid to high 70s cell mass fraction, which I think is an achievable number. Because aircraft have all these like unnecessary things like tails and like rudders and elevators. It's like not needed. just gimbal. Gimbal the electric fan. Like for some weird reason, like gimbaling motors is normal in rockets and not in aircraft. Why not?
Okay, well, it definitely plans to get into this business because we love to see how things develop in that particular area. Certainly a very interesting domain. Do you have specific plans?
I've been sort of toying with the design for an electric supersonic vertical takeoff and landing electric aircraft for a while. I'd love to do it, but I think my mind would explode. It's like brain's worn out, It's like pretty saturated working on electric cars and rockets.
Okay, good topic. So the last question I will ask is about our students. You've hired dozens of MIT graduates for your companies. The first question is, how are they doing?
Well, they're doing great. In fact, we want to hire a lot more people from MIT.
That's good news, and I'm sure a lot of people in the audience.
Definitely, apply to SpaceX, apply to Tesla, and like yell at me on Twitter if there's something wrong with our admissions process or something. That seems to be like, it's not the most efficient way to get to people, but that is one way. Because I don't know if like our recruiting and sort of and our process for hiring people is good, or I think it's good, but I'm not sure. So, but we want to hire lots of really smart engineers because that's how these problems get solved.
I read a quote, which I hope it's true, from you. Tell me if that's not the case. That you said that the most common hiring mistake was weighing too much on someone's talent and not on someone's personality. And then I think it matters whether someone has a good heart.
It does, yes, absolutely. So That's generally where, if I say where it's sort of the hiring mistakes that I've made in the past, it's been just as I said, it's looking too much at their intellectual capability alone, and not on how they affect those around them. What really matters is for someone's contribution to a company is how they are as an individual and how they affect others around them. I mean, you could say it's also analogous to a sports team. You know, if someone, the best person on the team is not necessarily the one who scores the most goals. It could be the person who assists in the most goals. And if somebody is, if there's one person on the team who's just wants the ball all the time and just wants to kick it at the goal, that can actually be detrimental. So it is important to weigh personality and just, you know, are they going to be a good person, and will people like working with them, and that kind of thing. It does make a difference.
Thank you. I'd like to invite the audience to ask some questions. I particularly like students to ask questions, but others are also invited. And one thing I will ask is that we keep the questions short so that we can have a few of those.
Okay,
Phil.
let's cut off. I'm Phil Chapman. What I'd like to ask you, Elon, is it looks as if the next decade or two, human spaceflight will be dominated by you and Bob Bigelow and other exopreneurs. The question is, what do you think the proper role of NASA human spaceflight should be in that context, other than just giving you contracts?
Well, NASA's been really helpful to SpaceX. You know, not just in terms of giving us contracts, but also technically in a number of areas. And a lot of the things that we've done at SpaceX have been dependent on things that NASA's done in the past. So, you know, I think we're certainly incredibly grateful for everything that NASA's done in the past, and for the ongoing support that we receive from NASA. So, I'm a huge fan of NASA. I think NASA is actually doing the right thing given all of the constraints that they have. Like if you know, within the context of being this large government entity that's getting pushed in all sorts of different directions and has a lot of limitations on what it can do, I've been pretty impressed with what NASA has done given all of those constraints. Yeah, so I think it's, you know, if NASA continues